Welcome to Brain Vision.
Let's use the chain rule to find the derivative of z with respect to t. And let's go to the side and draw a diagram here. We see that z depends on x and y, and then x and y both just depend on t. I recommend drawing this diagram based on the variables you're given because it makes it easier to use the chain rule. So using the chain rule here, well, one way to go from z to t is dz dx and then dx dt. The reason I'm using the partial derivative notation is because z has two variables. And the other way to go from z to t is to go from z to y, then y to t. So that gives us our second term over here, dz over dy, and then the regular derivative of y with respect to t. So that's one step, just writing out the formula for the derivative. But as you can see here, we have 4 computations. So first one, dz over dx. So for this, we can use the quotient rule. So the derivative of the top with respect to x is just 1. And then the denominator stays as it is, minus the original numerator times the derivative of the denominator with respect to x, which is just 1. Just put it times 1 there. So 1 at the end, just to remind you where that's coming from. And then you take that denominator in the bottom and you just square it. That's just using the quotient rule. And then in the numerator, we see that we'll have an x minus x. Those cancel out. And then we'll have a 2y plus another y, so that's 3y. We'll have to do another quotient rule, so let's just go to the side and do that one as well. That'll be dz over dy. So this time y is the variable. You take the derivative of the numerator, that's minus 1, times the denominator as it is, minus the original numerator, times the derivative of the denominator with respect to y, which is just 2, all over denominator squared. And we see that that simplifies. So you have a negative x over here, but then you're subtracting 2 more x's on the right. And so that'll give us a negative 3x on the top. And then how about for the y's? We have a negative 2y over here, and then a plus 2y, so the y's cancel. And then now we'll go to the side and do 2 more partial derivatives. So the next one is, these are just usual derivatives. And then dy over dt, using the chain rule again here. And now finally we have all the partial derivatives, so the next step is to just give ourselves some room here so we could write this all out. So dz over dx times derivative of x with respect to t. And then we'll have also here, notice that these negative signs will cancel out. So we could just keep this as a plus. And then we'll have 3x over this term squared. And then pi e to the pi t. And that's our final answer.